guys, today we are going to be attempting to shoot a ping pong ball through this Dr. Pepper can here. To power our ball, we have a vacuum cannon, which we created with 1.5 inch Schedule 40 PVC pipe. To draw the vacuum, we have 2/4 horsepower vacuum pumps that are linked together and come here to draw the vacuum, draw all the air out of the pipe. In order for this to work, we're going to have to seal both ends. To get a clean seal, we added O-rings on either side. That'll help us get a clean seal and draw a clean vacuum. The way this cannon works is we'll turn the pumps on once each side is sealed, and we have a ping pong ball in there, of course. We'll turn them on, draw a complete vacuum out, and then we'll puncture one side. And when we puncture this side, it's going to let in atmospheric air. The pressure differential, the higher pressure atmospheric air will push and want to fill the chamber of the vacuum, and in doing so, the ping pong ball will be in the way, will come down, and it'll shoot out at a high velocity. The reason it reaches such a high velocity is because there's no air resistance in the tube to slow the ball down because of the pure vacuum. So we're going to go ahead and get set up. We have our Dr. Pepper can and our little homemade rig that we built, and we're going to see if we can get the ping pong ball to go through the Dr. Pepper can. Alright guys, I failed to mention earlier that in a lot of the videos that I saw online of people doing similar things like that, they were just puncturing this hole right here to get the ping pong ball to come out. One of my design aspects to get the ball to go a little faster is I have this compressed air thing here. I mostly use it to blow sawdust off and various other things, so I'm hoping that the increase in pressure here will make the ball go a little bit faster. So we just picked up our can that we fired the ping pong ball into. As you can see, it ruptured it, but the interesting thing is that the ping pong ball is actually inside of it. So we'll crack this open, and there's your ping pong ball. Alright guys, we got our video queued up here in Windows Media Player. What we're going to be doing is I took a shot in front of this board here, and this is how we're going to calculate our velocity. These segments are 3 inches apart. So what we can do is we started in slow motion at 240 frames per second, so we can count how far it goes in between frames, multiply it by the frame rate, and then we should be able to get what our feet per second is, and then we can transfer that over into miles per hour. So I got it queued up. What we're going to do is we're going to take it frame by frame in Windows Media Player just to see what speed we got. So this is very hard to see. The ball is traveling almost faster than what our camera can keep up with. So that was the foil coming off, if you could even see that. And this is very hard to see, but this is the ball right here. This is the leading edge. Again, it's traveling so fast that it's pretty much just a blur. But I went ahead and took it as the front measurement being right here at 6 inches. We're going to go to the next frame and see what that distance is, and as you can see, you can barely see it, but it's traveling to about right here, right at the end of our board. We barely got it in frame. The board total, this is 33 inches, so this is 34 inches. Again, this isn't a perfect measurement, but it'll give us pretty close. So what we did is 34 inches minus the 6 inches, so we traveled 28 inches in between frames, which is 2.33 feet. We went ahead and multiplied that by our frame rate, which is 240 frames per second. So that gave us a rate of 560 feet per second, which is a little bit faster than what I was expecting. I was shooting for about 325 mph, so converting that over, that
560 feet per second gives us 381.8 miles per hour.